All right, so first problem. See if I can make the font a little bigger so that you might have a chance of actually reading this, right? Use the observation that the angular diameter of the sun, let me go up, right? So the angular diameter of the sun, and that its distance is 1.22 times 10, where we're missing something? Angular diameter of the sun is half a degree. We're missing something in this problem. Okay. So right here, right, this should have in it 0.5 degrees, right? So you can't do this problem without that piece of information. So I'm going to have to edit that shortly. All right. So diameter is half a degree. Distance is 1.22 times 10 to the 8 kilometers. All right. So distance 1.222 times 10 to the 8 kilometers. And its angular diameter, alpha, is 0.5 degrees. And the formula we have really? All right. Well, what's up with this problem? Okay. This is the formula, right? Here's the formula right here. L is 2 pi d alpha over 360. All right? And I do not know why this is not showing up correctly on Canvas.
When you take the quiz, it doesn't like show you the formula or the answers either. And it didn't show me like the correct answer or anything.
The answers it normally doesn't show you, but it should be showing you these formulas because they are part of the question. So I'm not sure why this one isn't working at all. But let's go over. So on this one, we have the angle is 0.5 degrees, right? In the version that we had, and we have L is 2 pi d, right, times alpha over 360.
When you work with, do you plug the whole thing in your calculator, like the whole formula?
When I do it,
Yeah. Like piece by piece.
so I often do it all at once, right? But I might have used a calculator more often than you,
Oh.
right? So that's something to think about, and you might want to think about, do I need to break it down in order to make it easier for you to do it, right? Okay, so 2 times pi times 1.222, and in Excel it's times 10 to the 8th like that, times 0.5 divided by 360, and what we get, right? 1, 2, 3, 4, 5, 6, right? What we get is L equals 1.06 times 10 to the 6th. Now, the way Canvas grades things, you only have to be within 2%, right? So you don't have to have it exactly right, just be within 2% and you're good. Yeah. accidentally magnified. See if I can get out of that. Or did I? Okay. So, I'm going to try and figure out why Canvas is messing up on this question when you see it, right? Why you don't see the formula and why you don't see the angle. I'll try and get that fixed today. If I don't get it fixed, right, the angle, the number, it was showing you this number just fine. The angle is 0.5 degrees, and the formula is 2 pi d times alpha over 360. All right? So if for some reason I'm not able to get it fixed, you'll have that. Let me see if I can see what I can do real quick. See if just okay. No. All right. Let's look at the next question. Calculate the sun's density in grams per cubic centimeter, all right? Sun's mass is approximately, oh, I need to lower that, and erase. Sun's mass is approximately 2 times 10 to the 33 grams, all right? And its radius is approximately, okay. Let's pull up. Oh, I have to save and hit preview again. Preview. Okay. So 2 times 10 to the 33 grams is the mass of the sun. Radius approximately 7.07 times 10 to the 10th centimeters. So what is the density of the sun? It's given by this formula. The mass, 2 times 10 to the 33 grams, divided by 4/3 pi times radius cubed. Now, here's one where it might make sense to break it up into 2 pieces, right? And calculate the denominator first. So the volume, that's what's on the bottom, is 4/3 pi r cubed, right? That's the denominator down here. R is 7.07 times 10 to the 10th. Right? So the volume V is 4/3 pi times 7.07 times 10 to the 10th cubed. So if I go over here to Excel, 4 divided by 3 times pi times 7.07 times 10 to the 10th cubed. So 1.48 times 10 to the 33 cubic centimeters.
So was it at the 3 times 3 on the outside?
What's that?
The 3 on the outside?
The 3 on the outside? What 3?
So you got 7.04 times 10 to the 25?
Yes, cubed, right? So 7.07 times 10 to the 10th cubed. And then the radius we had, or the mass we had, 2 times 10 to the 33 grams, right? So the density grams divided by cubic centimeters, right? So 2 times 10 to the 33 grams divided by 1.48 times 10 to the 33 cubic centimeters, and we get 1.35 grams per cubic centimeter.
Times 10 to the 66.
What's that?
I got 1.35 times 10 to the 66.
Then you ended up multiplying instead of dividing. Here's what you probably, let me show you what you probably did, okay? Let me finish writing grams per cubic centimeter. Okay, so what you probably did on your calculator to get that answer was you did, you typed something like 2 times 10 to the 33, right? Divided by 1.48, and then you went times 10 to the 33. When you do this, like this, you're multiplying by 10 to the 33, you're dividing by 1.48, and then you're multiplying all of that by 10 to the 33. All right? So one of the ways to help yourself when you have expressions like this is if you just put parentheses around it, like that, then it's taken care of. All right? Yep. Yeah, that's how you set it up.
So what, I'm guessing the 1.48 comes from 3, 4, 3, right?
The 1.48 came from the volume
Over here.
here. That came from the volume, 1.48 times 10 to the 33 cubic centimeters.
But we're on number 2, right?
Yeah. So we have mass. This is 4/3 pi r squared, r cubed, sorry.
So you got add 2 times 10 to the 33 power divided by 1.48, which was 4/3.
Which is 4/3 pi r cubed. Yep. We calculated the 4/3 pi r cubed first,
Oh.
right? We calculated that first, and now we're doing the division mass divided by that.
So what do we do with the radius?
Okay. Yeah, we've already used the radius, right? It's in the 4/3 pi r cubed, which was the 1.48 times 10 to the 33. All right? Now, and when you guys do this, remember, you're going to have slightly different numbers, right? Everybody clear on these? Ready for the next set? Yep.
Do you get your answer, would it be like something times 10 or something?
No, the answer on this one?
Yeah.
No, the answer on this one is just 1.35. All right?
Our answer is not going to be 1.35.
No, your answer is going to be a little different from 1.35. Are you having trouble getting that? What are you getting?
I'm trying to do it again, but I got. I got 0.8.
Oh. Yes, that is great. That's right. All right. Let's move on to the next one. We'll go back after we get through and look at calculator issues, okay? We'll go back after we go through all of it, and we'll try and sort out calculator issues for everybody. All right. Parallax, the red giant Betelgeuse. We can barely measure it, but we can measure it, and has a value of about, okay. What is up with Canvas? Because P
So if it's not showing up here, we have different problems, so what do we do if it's not showing up?
I'm going to have to contact the help desk to find out what's up with Canvas. Basically, because all right, I'm going to go in where I can see, we can at least work through a problem, but as it is, you don't even have all the information you need to solve these problems. Okay, so the red giant Betelgeuse, right? Barely measurable. I thought I did that. Has a value of P milli-arc seconds, it's the distance D in parsecs, right? And so the number we have for this problem is 5.139 is P. So in this problem, P is 5.139, that's milli-arc seconds. And so the distance D in parsecs is 1,000 divided by 5.139. Right?
So that 5 point, it's not gonna be the same now.
No. So 194.6 parsecs is how far away Betelgeuse is, right? So that's an easy one. The next one, I may have to just go in and, I don't know what I'm going to do yet. All right. $48.98. Okay. So the main sequence star has luminosity of 4898 times luminosity of our sun, right? So basically, what we're saying is we have L for this star is 4898 times the luminosity of our sun. Oh. All right, and that's the symbol for luminosity of our sun. What is its mass, m? Well, all we need is luminosity is mass cubed, and if we solve for mass, mass is L to the 1/3. All right. So here's one of the reasons I have this problem in here. Mass is the luminosity to the 1/3 power. Okay? All right. This is one you guys did not get right fairly often. Because here's what you did. You typed something like L to the 1 divided by 3. Right? What is that? You don't know? Here's what your calculator sees when you do that. L to the 1 divided by 3. That's what your calculator sees, right? So to avoid making that mistake, use parentheses 1 divided by 3 like that. All right? That way your calculator knows exactly what you mean when you do L to the 1/3 power. So if I'm going to do 4898 to the 1/3 power, 4898 to the 1 divided by 3. See, I use parentheses when I'm doing it so that we sort that out correctly. All right? 4898 to the 1/3 power, and I get 16.98 is the mass. So the mass is 16.98 times as massive as our sun. All right? Okay. See if it still messed up. And the answer is yes. And yes. Okay. Next problem. Okay, in the sun's core of 1 billion years, mass is consumed, all right, this is chapter 14. Mass is consumed at a rate of 1.33 times 10 to the 26 kilograms per billion years. Oh, it helped if I did that, right? Okay, so 1.33 times 10 to the 26 kilograms per billion years. The mass of the sun's core is about 10th the mass of the sun, and so the mass that we're concerned about is 1.989 times 10 to the 29 kilograms. How many billions of years should our sun be on the main sequence, right? The number of billion years it should be on the main sequence is just you divide the mass by the rate at which mass is being consumed, and you get the answer. So what we want, right? We have Q 1.33 times 10 to the, was it 26th? 26, all right, kilograms per billion years. We have the mass is 1.989 times 10 to the 29 kilograms. And what we're looking for is just the mass divided by the rate at which it's consumed. So 1.33 26 divided by 1.989 29, right? All right, again, when you type this and you want to calculate it, you're going to want to do,
Not the man's on top.
hmm?
Not the man's on top.
You're correct, mass is on top. All right, when you calculate this, don't hesitate to use parentheses and 1.989, right, times 10 to the 29, divided by 1.33 times 10 to the 26th, right? Do it that way, and that'll help you make sure you're calculating what you think you're calculating. So it's easier in Excel because I can just put E29 and 1.33 E26, and I get 1495 billion years. Any questions on that one? Okay. Question 2 in chapter 14. How long will it take for a planetary nebulous shell moving at 22.84 kilometers per second to expand to a radius of 1/4 of a light year? So 1/4 of a light year is 237 times 10 to the 12 kilometers. Time t in billions of years is that divided by the velocity times 10 to the minus 9, right? So we have, oh, sorry. Bring the problem down where you can actually see it, all right? So we have our velocity, 22.84 kilometers per second. We want to know how long at that velocity would it take to go 1/4 of a light year. And 1/4 of a light year is 2.37 times 10 to the 12 kilometers. Right? And I set this up so that when you get through calculating it, you multiply 10 to the minus by 10 to the minus 9, and you get the answer in billions of years. All right, so we have our velocity, v equals 22.84, all right? Apparently it is not my day for computers. Where our velocity, 22.84 kilometers per second. We have our distance, 2.37 times 10 to the 12th kilometers. All right? And we have our formula, T equals D over V times 10 to the minus 19.
So you would put everything in parentheses and get this?
All right. What's that?
We would put everything in parentheses and get this?
Might make it easier, right? So I would type this as 2.37 times 10 to the 12th, right? Divided by 22.84 times 10 to the minus 9.
Okay, you don't put that 10 to the minus 9 in parentheses.
Because that is multiplying the whole thing. right? It's not in the denominator, it's multiplying the whole thing. So 2.37 times 10 to the 12th divided by 22.84, all times 10 to the minus 9. $103.7 billion years. Or 8 billion years. Okay. Chapter 15. This looks like it's working. All right, so in chapter 15, first problem, right? We have a radius of 0.81 times 10 to the 9th. We have a mass of 1.989 times 10 to the 33rd. We're going to calculate the density, which is mass divided by volume, where volume is 4/3 pi r cubed. This is exactly like the problem we did earlier, just different numbers, right? It's exactly the same problem. Just calculating the density of a sphere. We've got its radius, we have its mass, and we just have to calculate its density. So radius, 0.81 times 10 to the 9th centimeters. Radius, mass, 1.989 times 10 to the 33 grams. The volume is 4/3 pi r cubed, right? So the volume we're after is 4/3 times pi times 0.81 times 10 to the 9th cubed. Divided by 3 times pi times 0.81 E9 cubed. So 2.22 times 10 to the 27th, or 2.23 times 10 to the 27th cubic centimeters. So the density that we're after is mass divided by volume. All right, so the density is 1.989 times 10 to the 30th divided by 2.23 times 10 to the 27th. So 1.989 E30 by 2.23 E27. 891.9 or 892. Right? Same as one of the problems we did before. Should be pretty straightforward. Last problem. Calculate the Schwarzschild radius of the sun, right? All right, so the Schwarzschild radius of the sun, 2 times g times the mass of the sun divided by the speed of light squared, right? G is 6.67 times 10 to the minus 11. C is 3 times 10 to the 8. Mass of the sun, 1.998, is I listed it here, 1.9998, 998 times 10 to the 30th kilograms, right? This gives us the mass of the sun. So, okay, 2gm, I'm going to leave off the little symbols saying, referring to the sun. So g, 6.67 times 10 to the minus 11. M, 1.998 times 10 to the 30th. C, 3 times 10 to the 8th. So R is going to be 2 times 6.67 10 to the minus 11 times 1.998 10 to the 30th divided by 3 times 10 to the 8th squared. So 2961 kilometers. Yeah. On the previous problem, I put in the wrong mass up here because this was in grams. All right, so that was supposed to be 33 right there, which means it would have been 33 right there, which means this was 0.892 grams per cubic centimeter, and that's on the previous problem. I just put in the wrong exponent on that first problem. I put in 10 to the 30th instead of 10 to the 33. Questions? I'm going to look back and see which ones. Chapter 15 seems to be working. Chapter 14 seemed to be working. Chapter 13 is not. And chapter 12 is not. Let me see if Oh. Preview again. Okay. Let's take a look. Okay. Angular diameter of the sun is A equals 0.5 of a degree, and that its distance D is 1.22 times 10 to the 8th kilometers. Determine the sun's diameter L. And now we have L equals 2 pi dA over 360. So number 1 on 12 is working now. Calculate the sun's density in grams per cubic centimeter. Sun's mass is approximately 2 times 10 to the 33 grams. Radius, 7.05 times 10 to the 10th centimeters. Okay. So that's good. All right. 12 is working. And this one on 13, the second one on 13 does not seem to be working. Nor does the first one. Value of so the first one on question 1 is now working, right? All right, let's see if I can go back and add in comments on question 2 to help you understand how to calculate that. No. All right. I think we've gotten to a place where we can at least live with what we got. So, all the problems seem to be displaying at least partially correctly enough to get you all the information. Okay, questions? Questions on any of this? Anybody having trouble repeating these calculations to the calculator when we go over it? All right, so anybody that wants help with the calculator and has questions, right? Stay, and we'll start going over it individually. Anybody that's good to go, I will see you for the test on
In Galapagos Islands, saving up all my money so I could go there. I really want to go really bad. Yeah.